Now let's go ahead and discuss multiplication principle, permutations, and combinations. I'm going to define them as we work through problems. That way the ideas make sense to you. So multiplication principle simply states that we can simply multiply the number of options in each category. So let's take a look at this problem. Suppose a menu offers a choice of 3 salads, 8 main dishes, and 7 desserts. How many different meals consisting of 1 salad, 1 main dish, and 1 dessert are possible? Well, so think about you have 3 different categories. So you got the salad, you got the main dish, and then you have a dessert. Now, how many options do we have for salad? Well, we got 3 salad options. So that's where you put 3 times. Now for the main dish, you got 8 options. And then for the next category, dessert, you got 7 options. So we simply multiply them. So that would give us about 168 possible different options. So that's how you use the multiplication principle. Now for permutation, we're going to be defining a little bit differently. So it's another way of counting, of course, but the way you order things does matter. So we're going to be defining it in the following way. So the permutation of n number of objects in our items, it's going to be defined as n factorial divided by n minus r factorial. So that will be the definition we're going to be applying for permutation. Now you have to keep in mind the way you order your objects makes a big difference. So here n is representing the total number of objects or items you have, and r is how much you're going to pick or how many you're going to pick out of the n items. So sometime you'll also see this is written as n pick r, just like that. So that's another way to represent that. Now in a club with 10 members, how many ways can a slate of 3 officers consisting of a president, vice president, and secretary or treasurer be chosen? So you got 3 different positions to give to 3 different categories. So let's think about it in terms of multiplication principle. You can always do that. So I have 3 different spaces, and I can have a president, vice president, and a secretary. So you got 10 members to choose from. So you can think of this is your total number of objects, and this is kind of like your R value, how many you're going to pick. So, well, there are 10 options for the first position, so 10 here. And now once you have chosen a person, now you only have 9 more left to give to the remaining position. So you have 9 to choose from. And then once you have chosen another person, then you only have 8 left to make your selection for the secretary or whatever the position is. So there you have it. This would give you the total number of possible choices we have, which would be 720. Now you can also treat this as a permutation problem. So we know the total number we have, our n, is going to be 10, and we're only going to choose 3 of them. So you can write this as n pick r. So n is 10. We're going to pick 3 of the 10. And using the formula I wrote above, this will be 10 factorial divided by 10 minus 3 factorial. And if you simplify this further, this is 10 factorial over 7 factorial. And if you can straight up put this in your calculator, or you can just simply rewrite 10 factorial, you can count down to 7 factorial. So it'll be 10 times 9 times 8 times. As soon as you get to 7, you can stop and say 7 factorial because we have a 7 factorial in the denominator. Now you can simply cancel these. So this gives you exact same thing we got when we use the multiplication principle right there. Now let's discuss combinations. So combination is also another way of determining the number of possible arrangement in a collection of items. Here, the order doesn't matter. So we have the formula. So n is your total number of objects, where r will be how much you're going to choose. So let's say choosing item. So our formula will be N choose R, or simply C N comma R. So you can also write it that way. And this is given as N factorial over N minus R factorial times R factorial. You can also think of this as permutation divided by R factorial. Since the order doesn't matter, we want to remove all the repetitions. So let's take a look at this problem from a standard 52 deck of cards. So this is the 52 deck of cards, as you can see it right here. So we have 4 different suits. We got the hearts, we got the diamonds, these are the red cards, and then we have the spades, and we have the clubs. So now we can, let's make following statement. So we want to know how many 7 card hands consist of 3 diamonds and 4 spades. All right, so our total number is 7, and we want to categorize this into 2 different categories, diamonds and spades. So diamonds, we have 13 of them. So each of these category has 13 cards. As you can count, there's an ace card, and we have numbers 2 to 10, and also the face card, jack, king, and queen. For each suit, you have those. So there are 13 in total. So now we want to know, well, let's think of it as a multiplication principle first. So I got 2 different categories, diamond and spades. So I want 3 diamonds and 4 spades. Now it doesn't matter which diamond card I have. I could get a heart, I could get a number 10, I could get a jack or a king, anything. Since the order doesn't matter, it's combination. So of the 13 diamond, we're going to choose 3 of them. So that's the first option. Times, now from the spades, again, which card we have, it doesn't matter as long as it's a spade card. So of the 13 spades, we're going to choose 4 of them. So you can see the total number of cards you're going to choose is sum of these 2. That will be the total, 7. Now here, you can use the formula we wrote above. So 13 choose 3, that will be 13 factorial divided by 13 minus 3 factorial times 3 factorial. Times, now 13 choose 4, that will be again 13 factorial divided by 13 minus 4 factorial times 4 factorial. And just simplify this as much as you can. So we got 13 factorial on the numerator. Then we have 13 minus 3, that's 10 factorial times 3 factorial times another 13 factorial over 13 minus 4, 9 factorial times 4 factorial. So when I put this in my calculator, for 13 factorial divided by 10 factorial times 3 factorial, I got 286. And for the second fraction, I got 715. And when you multiply these, you will get about 204,490. So that's how many hands of 7 cards consist of 3 diamonds and 4 spades. Here's our last example. So we want to find the following. A 4-person graveness committee is to be selected out of 2 departments, A and B, with 15 and 28 people, respectively. So A would have 15 people and B has 28 people. How many ways can the following committee be selected? All right, so for A, we want to select 3 people from A and 1 person from B. Now, again, it doesn't matter which person we're selecting, so it's combinations. So we have 2 categories, A and B. So again, this will be a multiplication principle along with combinations. So of the 15 people from A, we're going to choose 3 of them. Times, now of the 28 people from B, we're going to choose 1. So that's how you do the first part. And now these, you can use the formula or you can simply plug it into your calculator. When you do 15, choose 3 in your calculator, you'll get the number 455. And then when you do 28, choose 1, you're going to get 28. And then when you multiply these numbers, you're going to get about 12,740. So that's how many ways we can choose 3 from A and 1 from B. All right, now for the second one, we're going to choose 2 from A and 2 from B. So still adding up to 4 people. As you can see, will always add up to 4. Here, this is 3, this is 1, adds up to 4. Now we're just going to pick it from different category. So again, 2 spaces, 2 options. Of the 15, now we're going to choose 2. And of the 28, we're going to choose 2. So that's the second category. And now again, if you put this in your calculator using the formulas we have, 15 choose 2, that will be 105, times 28 choose 2, that's 378. When you put this in your calculator, you'll get about 39,690. So that's how many ways you can choose 2 people from group A and 2 from group B. Now let's try one more part. Let's take a look at this one. So how many ways can you choose all 4 from A? So we want, so again, 2 slots. You can think of it that way. You have, so from the 15, you're going to choose all 4 from group A. And from the 28, you're actually going to choose 0. So you're not choosing anyone from group B. So then if you again put this in your calculator, if you do 15, choose 4, you're going to get 1,365 times 28, choose 0, that's just 1. So this is really just 1365. So that will be the number of ways you can choose 4 people from group A.